first question. First question involves work. We're going to do a couple of work-related problems. John can paint a house in 32 hours. Eric can paint a house in 24. How long will it take them to paint the house together? Add them up and divide by 2, right? 28, right? Yeah, that'll make sense, except if you actually think about it. Good luck. Run fast. You'll win. All right. So if we say 28 hours, Eric's saying, wait a minute, I can do 24 hours just by myself. So why, if I get help, is it going to take me 4 hours more? Right? And all of a sudden you're like, oh yeah, 28 doesn't work at all, does it? As a matter of fact, if we just think about this a little bit further, suppose John's rate was 24 hours and Eric's rate was 24 hours. How long should it take them together? 12, right? So we know it's probably, so John's not quite as quick, so it's probably going to be a little bit more than 12, right? So now we got an idea. We're totally confused, right? Let's figure out where to go. Fortunately, we've got these great formulas. That is, rate is equal to distance divided by time. Instead of saying distance, you could also say work, the amount of work that you've accomplished. And if you multiply both sides by t, you get rate times time is equal to distance. And you divide by r, you get time is equal to distance divided by rate. Now, it depends on the situation. I'm going to show you how to use examples of all 3 of them during the course of this lesson. So we're going to start with really this middle one right here. Rate times time is equal to distance, or work is equal to the rate times the time. Now, how much work are they doing? How many houses are they painting? They're painting 1 house. So 1 is going to be equal to the work done by John plus the work done by Eric. For example, suppose John does 40% of the work and Eric does 60% of the work, then they'll do a full job. Okay? So what we need is a rate for John. Well, a rate will be 1 house every how many hours? 1 house every 32 hours. So I have rate times time, okay, and that's going to be his work. Do we know how much time it takes John? Do we know how much it takes? Yes, it takes John 32 hours. Do we know how much it takes John and Eric working together? We don't. So that will be our variable that we're trying to solve for. The amount of time, t represents the amount of time it takes both of them together. Plus, what's the rate of Eric? 1 house every 24 hours times time. And all of a sudden now I got a nice equation. 1 is equal to, this is t over 1. So when I multiply those, I get t over 32. T over 1 times 1 over 24 is t over 24. Got it. I got to solve that. Because you're excellent at solving equations, this will not be a problem at all. What is the least common multiple of 32 and 24? (96), very good. So we'll multiply top and bottom by 4, top and bottom by 3. I didn't say greatest common denominator, I said least common multiple. Thank you for trying. Love your effort. What do we get in the numerator here? We get 7t. What do we get in the denominator? 96. Everybody clear with how I got 7t over 96? How do we then solve for t? 96 is equal to 7t. So t, or the time, is equal to 96 divided by 7, which is equal to, somebody give me a number here. That's not a fraction, give me a decimal. 13.71 hours. And you guys told me that if they both had 24 hours as a rate, then it would be 12. But John's going to slow that down a little bit. So does 13.71 seem to be a reasonable solution? It sure does. A little bit different than the 28 that we first thought, isn't it? Okay. Got it. Let's do another one. Somehow I started talking about Matt and Sue, but I inserted John back into the problem. John is not here anymore, so get lost. So we've got Matt back here. Awesome. All right. Sometimes I wonder, like when I wrote those problems, I was probably watching Monday Night Football or something when I was doing it. You know what I mean? And whenever I write up the notes, I always do it at home. So Vikings must have been playing bad or something. All right. Matt and Sue can paint a house in 5 hours if they work together. If Matt can paint a house twice as fast as Sue, how long would it take Matt to paint the house alone? What's different about this problem? Okay, you know how much time it takes both of them, but what you don't know is the rates, right? And that's what we're looking for. So it could be the same type of situation. How many houses are they painting? One. So again, you need Matt's work plus Sue's work. Well, I know how much time it takes them. It takes them five hours. But I need to write an expression for the rates. I'm going to start with Matt's rate. I'm going to say that Matt paints one house in 8 hours. Could somebody then give me an expression for Sue's rate? One house in 2H. So for example, if Matt could paint one house in 20 hours, then Sue could paint one house in 2 times 20, which would be 40 hours. Does that make sense? Okay. So, no big deal. Now we got it. Remember that rate times time is equal to the amount of work that you get done, or distance. So the rate is 1 over h times 5. Takes them 5 hours together. Plus Sue is 1 over 2h, and again together it takes them 5 hours. Now I have an equation, and remember it's 5 over 1. As I multiply, I have 5 over h plus 5 over 2h is equal to 1. How to solve, how to solve. Okay, multiply top and bottom by 2. So what's in my numerator now? 15 over 2h equal to 1 over 1. How do I solve? Cross multiply. 2h is equal to 15. H is equal to 7.5 hours. Does h represent Matt's rate? Yes, one house every 7.5 hours. Sue is one house every 15 hours. Correct. So work problems, those are a little bit different, aren't they? You would have struggled to find that on your own. So I show you the ticket, okay? But I'm not showing you the ticket necessarily number 14 or number 22, okay? Those are ones you kind of want to struggle with a little bit. All right, 2 planes. Love this one. Got 2 more problems left, and you guys can have work time. 2 planes are flying toward one another. It's kind of scary. Air traffic controllers, most stressful job in the United States. Next to President of the United States and stockbrokers. Then math teachers. No. So, yeah, air traffic controllers can't let the planes hit. It's a bad thing, right? Lots of multivariable calculus going on. Not 2-dimensional, but 3-dimensional, right? Woo! Yeah. Go get that job, folks. Lots of vacation time. Wow, that sounds awful. Like, it's kind of like if you have a mistake like once a year, it's kind of a bad deal. You know what I mean? Like, one mistake a year doesn't work out too well, right? So, all right. So they're flying toward one another. The plane flying from LA to New York is traveling at 500 miles an hour. Plane flying from New York to LA is traveling at 650 miles per hour. How long, or I'm wondering time here, the question. How long have they been flying? So what duration of time have they been flying when they meet if the cities are 2,450 miles apart? So the length of the segment is 2,450. That's your flight from LA to New York. So miles. So do you agree that this is a distance, rate, and time problem? So here's a strategy that I have for trying to figure out, how we set it up. We have distance, we have rate, we have time. Tell me, have they been flying at the same rate? No. Will they fly the same distances? Okay, so Jake, stand up. Stand at the door. Jake is the plane from New York. You're going to be traveling at a faster speed than me. So you're going to walk at a good clip when I say go. And I'll be the plane from LA, okay? Are you ready? Set, go. Boom. Like a brick wall. All right, so did we travel the same distance? Give Jake a round of applause. He's excellent at walking. I mean, if anybody ever told you you're bad at walking, they are wrong. You're good. All right, so the fact is that the distances were not the same, were they? Were the rates the same? Did we take the same amount of time before we finally reached? Yes. We were walking for the exact same amount of time. We were both walking for, say, 2 seconds, right? So the time is the same. So what I want to do is I want to grab my equation. Distance is equal to rate times time, but I want to solve for time. Distance divided by rate is equal to time. If the times are the same, I can simply set them equal to each other, correct? So I'm going to take the LA one and set it equal to the New York one. So I need to come up with an expression for the distance and divide it by the rates. I already know the rates. The rate of the LA one is 500. The rate of the New York one is 650. So now I'm going to come up with the distances. Another volunteer. All right, thank you, Michael. Tell me when you think I've reached the point at which they will meet. Okay, great. So we'll call that x. So that distance is x. What do you want to call the other distance? Awesome. But I don't like two variables, so how can I get rid of that y variable? What's an expression that relates x and y together? X plus y is equal to what? 2,450. So therefore, y is what? Now I have an equation that has just one variable. So again, I had two unknowns, so I needed two equations, substitute something in. Can we solve this? Cross multiply. Take out your calculator so you can multiply. 500 times 2,450 is 1,225,000. It's like my bank account. Minus 500x equals 650x. That's no big deal to solve, right? 1,225,000. is equal to 1,150x. Divide both sides by 1,150, and we get x is awesome. You guys, just for reference, I normally round things to the nearest hundredth in my class. So as you're wondering about rounding, that's the habit that I get into. All right. So does that answer the question? The question is how long or what timeline, okay? And we had a formula for time. We said the time was equal to the distance that it traveled divided by the rate at which it traveled. So what's its distance? That's how far, but the question is how long in terms of time. Which one? 500. This refers to the LA plane, so I'll take 1,600. I'm sorry, 1,065.22 and divide it by 500, and I get 2.13 hours. I took 1,065.22 divided by 500. Because in order to figure out time, I take distance and I divide it by rate. Okay, you hanging in there? One more problem involving distance to time, okay? After robbing a bank in Dodge City, robber gallops off at 14 miles per hour. I love Westerns. I love them. They kind of new ones. Have you ever seen 310 to Yuma? That's a phenomenal movie. Russell Crowe's in it. A lot of good actors. Gotta watch 310 to Yuma, folks. 10 minutes later, the marshal leaves in hot pursuit at 16 miles an hour. How long does it take the marshal to catch up with the bank robber? All right, let's think about it. We got distance, we got rate, we got time. We all know that that's what it involves. But what's the same? Is the rate the same? Will they have been traveling for the exact same time? No, because the robber takes 10 minutes longer, right? So have they been traveling the same distance? They will eventually have traveled the exact same distance. They both leave the station and they'll overtake each other after the same distance. You're just confused. Don't worry. You're just don't worry. You'll be fine. You got it. Yes, it is time for nap, isn't it? I'll show you what to do when you feel like it's time for nap. I'll show you. So yeah, we'll show you what to do. I'll tell you. No. Here we go. So I need the robber distance. And I need the marshal distance. Is marshal spelled with 2 L's? I really don't know. But I do know this. I do know that distance is equal to rate times time, which is much more important than spelling the word. So what is the rate of the marshal? Not a trick question. 16 times T. T being the amount of time marshal has traveled. Okay? This isn't the amount of time that the bank robber has been traveling. He's been traveling 10 minutes more. Agreed? Okay. So that's equal to, now we got to do the robber's distance. What's the rate of the robber? 14 times the amount of time that the marshal has been traveling. But he gets a head start, doesn't he? Plus, so then a distance to account for that 10 minutes. During that 10 minutes, what's his rate? His rate is always 14, okay? How much time has he been already traveling at 14 miles an hour? 10 minutes, which is what fraction of an hour? 1/6. He's got a head start. Right? He's got a head start. Okay, so we'll figure it out. So I got 14t plus 14 over 6, or 7/3, is equal to 16t. Now what? So 7/3 is 2t. 7 over 6, or dividing by 2 is the same as multiplying by reciprocal, or 1/2, which gives us 7 over 6, equal to time, which is 1 hour and 10 minutes. So that's how long the marshal has been traveling for. How long has the bank robber been traveling for? 1 hour, 20 minutes. Okay. So there's a nice introduction to distance, rate, time, and work problems. How do you like that? Yep. Here's our schedule. Tomorrow, we have one problem. The rest of your time is work time. You have work time right now. You have a test. You have study guide. I give it to you right now. You have all day money to work on the study guide. You have a test on Tuesday on this material. Test on Tuesday. What? Tomorrow? Okay. We'll see how things work. Just like last week, we'll plan accordingly. Yes. Yeah. Oh, yeah.